To another one of my Leetcode videos. In this one, we'll do Leetcode 2485, find the pivot integer. This is an interesting math problem, and it says, given an integer n, find the pivot integer x such that the sum of everything between 1 and x inclusively equals the sum of everything between x and n inclusively. And if there is no such integer x, we return -1. So if we look at this problem, let's walk through an example. So let's say we have numbers 1 through 8, and in this case the pivot integer is over here, 6, as provided in the example. The sum of everything from 1 to 6 is 21, as you'll find, and the sum of everything from 6, 7, 8 is also 21, as provided here. And so 6 is the pivot integer because 1 to 6 is equal to 6 to 8. So basically we have a sum that goes from here up to here, and then another sum that goes from here up to here. This sum over here from here to here is basically, it's going to be p times p plus 1 over 2, because that's the mathematical formula for the sum of everything from 1 to p, right? Or for simplicity, let's call this x. How do we get this sum? Well, this sum over here is simply the sum of everything from 1 to n minus this, right? But then that would exclude 6 because 6 is part of this, and then plus 6 because we need to include 6. So basically that's going to be the whole sum is basically n times n plus 1 over 2, right? That's the whole sum. And then minus, we have minus x times x plus 1 over 2, right? Because we subtract this sum, and then we add x because since 6 was subtracted, we need to add 6 because 6 has to be part of this sum. So we need to solve for this equation where this will be equal to this, right? Expand this equation. I'm going to move this term. I'm going to add this term on both sides. So what we'll have is x times x plus 1, because this is x times x plus 1 over 2, and this is negative x times x plus 1 over 2. So when you move it over here, both of the halves will make a whole. So that's just going to be x times x plus 1 over 2 equals n. And then I'll move this one to the other side as well. So I'll subtract x from both sides. So we'll have minus x equals n times n plus 1 over 2. And since we're given n, this is basically a constant. We can easily compute this. Distribute this, it's going to be x squared plus x minus x. So this part's going to be x squared plus x, and then this is minus x. So this, we can just erase this, equals n times n plus 1 over 2, right? So, and then, so basically x is just the square root of n times n plus 1 over 2. That's our x. So let's write the code. We'll convert it to a double because we need to divide it by 2. So we say double sum to n is equal to n times n plus 1 over 2. So that's this one. And then we'll say double x is equal to math dot square root of sum to n. But it could be now that this is not an integer, because there might not always exist an integer in case it'll be -1. So to check if this is like a whole integer, what I'll do is just like if x is equal to math dot floor x, so if you take the floor of x and it's still the same as x, then it's an integer, then we return int x, otherwise we return -1, right? So now let me just comment this out. Great, now let's run the code. Cool, accepted, and let's submit. Perfect. So thank you so much for watching. I'll see you in the next one.